Hey there, and welcome! Today, we're going to dive into the fascinating world of optics. We're going to break down the fundamental rules of light, the super simple principles that literally govern everything you see. And I promise, by the end of this, it's all going to click. So, let's start with something you've probably seen 1,000 times. You take a perfectly straight straw, pop it in a glass of water, and bam! It suddenly looks like it's broken right at the waterline. So what on earth is going on there? Now, you could crack open a textbook and get slammed with a bunch of jargon. Things like angle of incidence, refractive index, Snell's law. And it can feel pretty intimidating. But here's the thing. It's not magic. And it's nowhere near as complicated as it sounds. It's just physics. In fact, the whole mystery of that bent straw and so much of how we see the world really just boils down to two core ideas. Just two words: reflection and refraction. Once you really truly get these two concepts, you've pretty much cracked the code of optics. Okay, so before we can even talk about light bouncing or bending, we have to lock in its number one, most fundamental rule. And this is a big one, so really let this sink in. On its own, light always travels in a perfectly straight line. Just picture a laser pointer, right? That beam doesn't wiggle or curve, it shoots straight from point A to point B. And not only is it straight, it's almost unbelievably fast. In a vacuum, light zips along at a staggering 300,000 kilometers per second. To give you an idea of how fast that is, light can circle the entire planet more than 7 times in a single second. It's just mind-blowing. So, if light's default setting is perfectly straight, when does that ever change? Well, only when it runs into something. And when it hits a new surface, it basically has two choices. It can either bounce off, which we call reflection, or it can pass through it and bend, and that we call refraction. And this right here is my favorite analogy for understanding all of this. This is the key. Just imagine you're running at full speed on a paved road, and you hit a sandy beach at an angle. What happens instantly? You slow down, right? The sand is way harder to move through. And because you slow down, your path naturally bends. Well, guess what? Light does the exact same thing when it goes from something thin, like air, into something thicker, like water. It's really that simple. Okay, let's tackle that first idea, reflection. I like to call this one the big bounce. It's the easier of the two to grasp, and it's the reason you can see yourself in a mirror every morning. So, what is it exactly? Well, reflection is just what happens when light hits a smooth, shiny surface. Think a mirror or the top of a calm pond, and it bounces right back into the medium it came from. The key here is that it doesn't go through the surface, it bounces off of it. Now, to really understand reflection, we need to meet the 3 key players. First up, we have the incident ray. Just think of this as the light that's coming in. Then you've got the reflected ray. That's the light bouncing out. And finally, and this is the most important one to remember, we have the normal. Now, the normal isn't actually a ray of light. It's just an imaginary reference line we draw. It's always at a perfect 90-degree angle to the surface, right where the light hits. Think of it as our guidepost. And here's the really cool part. Reflection isn't random at all. It follows 2 very simple, predictable laws. Law number 1, the angle the light comes in at is the exact same as the angle it bounces out at. Simple, right? And law number 2, the incoming ray, the outgoing ray, and our imaginary normal line all sit on the same flat plane, like you drew them all on one sheet of paper. Okay, now listen carefully because this is crucial. This is the number 1 mistake people make when they're learning this. You always, and I mean always, measure your angles from that imaginary normal line, never from the flat surface of the mirror itself. If you can just remember that one thing, you've basically mastered reflection. All right, feeling good about reflection? Let's move on to the second big concept. If reflection was the big bounce, then you can think of refraction as the big bend. This is the one that's going to solve our straw mystery. So what is it? Refraction is the bending of light that happens whenever it crosses the boundary from one material or medium into another. Like from air into water, or from air into a glass lens. And why does it bend? Go back to our beach analogy. It bends because it's forced to change speed. That's the whole secret. And just like reflection, this bending follows some clear rules. When light goes from a rarer or thinner medium like air into a denser or thicker one like water, it slows down. And when it slows down, it bends towards our friend the normal line. But if it's going the other way, from denser water back out into rarer air, it speeds up and bends away from the normal.
I know that can feel like a little much to remember, so let me give you a super simple memory trick. Just remember this phrase: denser equals closer. When light enters a denser medium, it bends closer to the normal. That's it. That one little phrase will get you the right answer every single time.
And this brings us right back to where we started. The straw in the glass isn't vent at all. What's really happening is that the light bouncing off the part of the straw that's underwater has to travel from dense water into rare air to get to your eye. When it crosses that line, it speeds up and bends away from the normal. But your brain doesn't know that. It assumes light always travels in a straight line. So it traces that bent ray backwards and creates a virtual image of the straw in the wrong place, making it look broken. The light is bent, not the straw.
Okay, so we've got the big bounce and the big bend. We've seen how they work separately. Now, for the grand finale, let's put them together and see the whole picture at once. This is optics in one shot.
So let's follow the journey. Step 1, a ray of light is cruising through the air. Step 2, it hits the surface of the water. Now what happens? This is the cool part. Step 3, some of that light reflects. It bounces right off, following the law of reflection. Angle in equals angle out. But at the exact same instant, step 4, the rest of the light refracts. It pushes into the denser water, slows down, and bends towards the normal. Reflection and refraction happening together at the same time. That's the complete picture. And that's really the key to all of this. So much of what feels complex in science is really just a few simple, elegant rules playing together. The moment you stop trying to just memorize words and instead start to visualize what's actually happening, like our runner hitting the sand, it all just clicks. Because science isn't about memorizing things. It's about truly understanding them. Thanks so much for watching.